Hello, welcome back to geometry. We're going to do our second day of 8.1 special right triangles today. So these are kind of right triangles still, but instead of using the Pythagorean theorem, we're going to learn how to do a couple of shortcuts. So looking here at this, at these squares, we have squares at all equal sides. We're going to draw a diagonal and then calculate using the Pythagorean theorem the length of each diagonal. Okay, so in this case here, this will be 1 squared. Get my pencil here. I have 1 squared plus 1 squared would equal my hypotenuse squared, which I will call x squared. Okay, so 1 squared is 1 plus 1 equals x squared. That is 2 equals x squared. And if I take the square root of that on each side, x is going to equal the square root of 2. And that's the length of my hypotenuse. Okay, but what about this square here? We have a length of 3 on each side. So we take our 3 squared plus our 3 squared. That's going to again equal our hypotenuse squared. 9 plus 9 equals our hypotenuse squared. So we have 18 equals x squared. And if we take the square root of that, 18 is 9 times 2. So the square root of 9 is 3. And then when the square root of 2 stays inside. And now you know why you need to learn how to simplify square roots. So this length here is 3 square root of 2. And this is 1 square root of 2. So what if we just have the length of x on each side? Just some sort of length of x. Well, or actually, let's go ahead and, instead of x, because we're using x for a hypotenuse, so I'm going to call this a, side A. Okay, so if we have a squared plus a squared, that's going to give us x squared, our hypotenuse squared. This is going to become 2a squared equals x squared. And I'll take the square root of each side. The square root of a squared is a, and then of course the square root of 2 stays inside. So it's a squared of 2. And so what you'll notice here is a pattern, right? For each of these triangles or squares, whatever my length of my side is, my diagonal is the length of the side times square root of 2. My length of my side times the square root of 2. My length of my side times the square root of 2. So this gives us a special triangle and a special pattern that we can use whenever we come across a special right triangle. And you'll notice if this diagonal here would bisect this right angle, leaving this with a 45-degree angle here and a 45-degree angle here. So this is called a 45-45-90 special right triangle. So this leads us to our theorem for a 45-45-90 special right triangle. So instead of having to do a Pythagorean theorem every time, we just know that whatever the length of my side is here, my hypotenuse is going to be the length of my side times the square root of 2. And so we can kind of take a quick shortcut finding those values. Okay, so let's go ahead and try it here. So we have this triangle here in part A. My length of my side is 8. And I know that's a side because it's with my right angle. So my length of my side x is also going to be length 8, which means my hypotenuse, remember my hypotenuse is always equal to the length of my side times the square root of 2. So my y here is going to be my length of my side 8 times the square root of 2. Okay, well this one then give you the hypotenuse, right? So remember that my hypotenuse is equal to my side times the square root of 2. So if I plug in 18 here, or 19 equals my length of my side times the square root of 2, then I can divide by square root of 2 on each side. Well, remember from our simplifying that we can't have a square root on the denominator, so we're going to have to go ahead and rationalize this denominator. So I'm going to multiply the top and bottom by the square root of 2. And that will leave me with my side length equal to 19 times the square root of 2 over the square root of 4, which is just 2. And that is going to be just the length of my side here. So this side is going to be 19 square root of 2 over 2. And you'll start to notice a pattern as you rationalize these denominators and use those patterns. Okay? So you might want to pause this and try it on your own and see how you do and come back and see how you do. So if my length of my side here is 7, that means my other side has to be 7 because it's like a square, it's equal, okay? And this one over here, my hypotenuse will be 7 square root of 2. Pretty simple, right? Okay. How about this one? Go ahead and try this one. So again, if my hypotenuse equals 2 times the square root of my square root of 2 times my side, excuse me. Then I'm going to have my hypotenuse is 12 square root of 2 equals my square root of 2 times my side. Then I'll divide by square root of 2 on each side. And of course, these will cancel out here. And I'll be left with my 12 equals my side length. So my side lengths here are going to be each just 12. And that makes sense, right? Because my hypotenuse is 12 square root of 2. Okay, so now we're going to look at a different special right triangle. And in this case, we have an equilateral triangle. So that means that this angle down here is 60 degrees. This one is 60 degrees. We draw an altitude here. This is 90 degrees. So that splits this angle up here. So that makes this 30 degrees and this 30 degrees. Okay, so we're really looking at this triangle right here, when the special triangle is a 30, 60, 90 right triangle. Okay, so if this side length is 10, that means this entire side length is also 10, which makes half of this side 5 right here. Okay, that's half of my side is 5. So we want to find out what is the length of x right here. Okay, this 30, 60, 90 special right triangle. Well, we're going to take our x, our 5 squared down here, plus our x squared, and that should equal our hypotenuse 10 squared. So 25 plus x squared equals 100. And I'm going to subtract this 25 from each side. So x squared equals 75. And now I'm going to take the square root. And 75 can be split into 25 times 3 times 3. So x equals, the square root of 25 is 5, and we're left with the square root of 3. So this side right here is equal to 5 square root of 3. Now take a minute there and try to absorb that pattern. So we're just looking at this triangle here again, this 30, 60, 90 triangle. Okay, here's my length of my shorter side. My hypotenuse is double that side, and this one is 5, the shorter side, times the square root of 3. Okay, now let's see if this continues. Let's do another side. Okay, so this time we have this length is 3 over here also. This one is going to be half of that, right? Because it's half of the whole length of the side. So 3 divided by 2. Okay, let's find out what this length is there, that x also. So x squared plus 3 over 2 squared, that has to equal my 3 squared. So x squared plus 9 over 4, square both the top and bottom, equals 9. So let's subtract 9 over 4. Whoops, that's a 4. Subtract 9 over 4. X squared. So we have a fourths here, so we're going to have to convert this into fourths. So that means I have to multiply top and bottom by 4. So this will convert into 36 over 4. 36 subtract 9 is going to be 27 over 4. Okay, so now I'm going to take the square root of the whole thing. That's the square root of 27 over 2. The square root of 4 is 2. Now 27 is 9 times 3, right? So the square root of 9 is 3, and then we're left with the square root of 3 inside and over 2. So this is 3 square root of 3 over 2. Okay, and you'll notice this is 3 halves. That's half of this guy, or this is double that guy. And this is 3 halves times the square root of 3. So we have another special pattern here for this special right triangle. Okay, so if you look at this guy here, if we have a side length of s, that's my short side. So my short side is always my bearing side. That's the one we always kind of start from. And that means my hypotenuse here is going to be 2 times the length of that side, because it's sort of a mirror image of an equilateral triangle. You can kind of remember that. Okay, and then my altitude piece here is always going to be the length of that side, that short side, times the square root of 3. Okay, now these you just have to remember. Okay, so whatever you need to do to remember and memorize those ratios, that's what you got to do. Okay, so we have a 45, 45, 90 special right triangle and a 30, 60, 90 special right triangle. We still use Pythagorean theorem. Okay, so if the right triangles don't fit any of these special right triangles, then we still have to fall back on our Pythagorean theorem. Okay, so let's apply some of these ratios to these practices here. So we have our short side here is 5. That means my hypotenuse is going to be 2 times 5, which is 10. And this long side will be 5 square root of 3. Okay, that's it. Now this one's going to be a little more involved because we have this long side. So this long side here, 20, is equal to my short side, y, times the square root of 3. Okay, so then I'm going to have to divide by square root of 3. So I have 20 over square root of 3 equals y. And remember, I cannot have that radical in the denominator, so I'm going to need to rationalize that denominator, multiply by the square root of 3 on top and bottom, and we'll end up with our y equals 20 square root of 3 over 3. So right here, 20 square root of 3 over 3. And that means that this hypotenuse is going to be 2 times that guy. Okay, so we're going to go 2 times, we'll go 20 square root of 3 over 3 multiplied by 2 over 1. Okay, so we just take 20 times 2, 3 times 1, so it's going to be 40 square root of 3 over 3. So you don't need to multiply the radical by 3, only multiply the numbers by 2, okay? You don't need to multiply the radical by 2. Okay, so let's look at this other one now. We have our hypotenuse now. So if our hypotenuse is 32, that's double what this is. So this is going to be half of that, which is going to be 16. And our long side is going to be that short side, 16 times the square root of 3. Okay, and those are our ratios of our special right triangles. So you might want to go ahead and do this one on your own and see how you do. So we have our short side here is 6. That means my hypotenuse will be 12, double that. And our long side here will be 6 square root of 3. Okay. How about this one? We have our long side here is 9 square root of 3. That means our long side, 9 square root of 3, equals my short side times the square root of 3. So that means I just get to divide by square root of 3 on both sides. Those will cancel out, so my short side equals 9. Okay, and then my hypotenuse will be double my short side, which will be 18. Okay, so you can kind of tell my short side is sort of the beginning part for each of these. Okay, so Alejandro needs to make both the horizontal and vertical supports, A, C, and AB for a ramp. Is one 12-foot board long enough for both supports? So let's find the lengths of those sides so we can figure out if it's long enough. So if my hypotenuse here is 10, that means that my short side here is going to be 5, half of that. This is going to be 5 times the square root of 3. Well, what is 5 times the square root of 3? Let's actually find the length of that. And that is going to be about 8.66. So we'll call it 8.7. And we take that and add it to 5, the whole length of BA plus AC is going to be about 13.7. And so a 12-foot board is not going to be long enough. He's going to need to purchase another board or use another board, okay? Because they'll think those two sides together are about 13.7 feet. Okay? How about this one? Olivia starts an origami paper crane by making a 200 millimeter diagonal fold. What are the side length and area of the paper square? So if 200 millimeters is my diameter, my side length, my hypotenuse equals my side times the square root of 2. This is a 45, 45, 90. Okay, so my 200 is my hypotenuse equals my side length times square root of 2. So divide by square root of 2 on both sides here. And we get 200 divided by square root of 2 equals my side length. And remembering that I need to rationalize this denominator, square root of 2 over square root of 2. Okay, that's going to give me 200 square root of 2 over 2. And this time I can simplify. 2 will go into 200, and that will be 100 square root of 2 for my side length. Okay, so each side is 100 to square root of 2. Now to find my area, I just got to square that because it's a square, right? So 100 square root of 2 squared, so side times side. That's going to give me 1,000 times 2, basically, because the square root of 2 squared is 2. So that's going to give me 2,000. I'm sorry about that. This should be 10,000. So it'll be 20,000. I knew something was wrong there. Okay. And so my area is going to be 20,000 square millimeters of that piece of paper. Okay. All right, so what about A, B, and B, C here? If this is 28, this is my short side square root of 3. So my 28 equals my short side times the square root of 3, right? So I'm going to divide by square root of 3. So my side equals 28 divided by the square root of 3. And I'm going to go ahead and multiply by square root of 3 on top and bottom. So side equals 28 square root of 3 over 3. So that's this guy here, 28 square root of 3 over 3. To multiply by 2, so I'm going to take 28 square root of 3 over 3. To multiply by 2, you can turn 2 into a fraction, so just 2 over 1. Multiply 28 by 2, that will give us 56 square root of 3 over 3. Okay, so 56 square root of 3 over 3. And I don't think 56 is divisible by 3. It is not, so we're going to leave it in that form. Okay, no decimals. We're just keeping it all in simple radical form. Okay, how about here? AC and BC. And this is a 45, 45, 90 square root, or right triangle. So we know that our hypotenuse, 14, equals my side square root of 2. So I'm just going to divide square root of 2 on both, square root of 2 on both sides. So 14 divided by square root of 2 is equal to my side. And I need to rationalize this denominator. And so it's 14 square root of 2 over 2 equals my side. 14 divided by 2 is 7. So my side length is equal to 7 square root of 2, 7 square root of 2 on each of those. It's a 45, 45, 90 isosceles right triangle. Okay, how about this one? Now this is careful here because this is not a 45, 45, 90 right triangle. So you can't use those special relationships. It's not also a 30, 60, 90. It doesn't say 30, 60, 90 on it, so you cannot assume that. So be careful with that. So here we just have to use our good old Pythagorean theorem. Okay, so 8 squared plus 15 squared equals c squared. Okay, 64 plus 225 equals my c squared. So this ends up being 289 equals my c squared. Take the square root, and I believe that is 17. Okay. So be careful on those. Make sure you're not applying special ratios for special right triangles when they're not special right triangles. Okay. Okay, so here is all of your Pythagorean theorem for any right triangle. Okay, my converse says if it's a right if a squared plus b squared equals c squared is a right triangle, then the Pythagorean theorem applies. For 45, 45, 90 right triangle, this is my relationships of my sides. And for 30, 60, 90, you might want to write these down somewhere. And actually, what I like to put it right on here. So this is 2s. This is s squared root of 3. And this one right here, if this is my length of my side, this is equal to the side, and this is side square root of 2. So you might want to write those down somewhere, okay? All right, and then you guys have an assignment in Google Classroom, 8.12, and I will talk to you next week. Thank you very much. Bye-bye.